In 1969, humanity accomplished an incredible feat of engineering, sending Neil Armstrong down a ladder to the lunar surface. The Apollo guidance computer that navigated that journey ran on hardware like this rope memory module, operating at a speed of 0.043 megahertz, with exactly 4 kilobytes of RAM. If you pull out your smartphone right now, you hold a device with over 100,000 times more processing power than that moon landing computer. For decades, we were limited by physical machines. We spent years making chips smaller and faster. Today, the hardware is no longer the bottleneck. The new frontier is the software running inside those chips. With hardware no longer posing a physical constraint, the attempt to make software actually think and act intelligently has become the most crucial technological leap of our generation. This brings us to artificial intelligence, or AI. For a long time, pop culture and science fiction have trained us to picture AI as a physical, metallic robot wandering around a museum. AI is a software program, not a physical machine with a face or an entity preparing to take over the world tomorrow. The reality is much more practical. AI is a system built entirely on mathematics, statistics, and logic. Once we drop the Hollywood myths, the fear disappears. We can look at AI for what it actually is, a highly advanced digital tool that we design, control, and use every single day. How exactly does this intelligent software differ from the standard computer programs we have relied on for the past 50 years? Look at this vintage IBM computer room. Traditional computers like these operate like super-fast calculators, strictly following a rulebook written line by human programmers. Compare that to the human brain. The brain doesn't come pre-programmed with a fixed manual for every possible situation. Think about how a baby learns to walk. They don't read instructions. They learn by trying, falling down, making slight physical adjustments, and trying again. AI is the engineering attempt to replicate that exact process. Instead of writing a manual for a computer, we give it a task and let it learn through its own trial and error. That shift, moving away from executing rigid human-written instructions and moving toward a system that learns from examples, is the defining difference between standard software and artificial intelligence. Because AI systems learn from examples, computer scientists categorize them based on how many different types of tasks they can master. This image shows Garry Kasparov playing against Deep Blue. This is an example of narrow AI. Narrow AI is software that is an absolute genius at one highly specific task, like playing a complex board game. That same world-class chess AI doesn't know how to translate and can't recommend a movie. It only knows chess. The overarching goal of the field is to build what you see represented on the right, general AI, or AGI. Artificial general intelligence is a system capable of adapting, reasoning, and switching between completely different tasks, just like a human can. We are still working toward that goal. True general AI does not exist right now, which means every single piece of smart technology you interact with today is strictly narrow AI. You are likely interacting with narrow AI constantly without even realizing it, right on your smartphone. When facial recognition unlocks your screen or your keyboard auto-completes your sentences, that's an AI analyzing past data, predicting what you are doing right now. This flowchart illustrates how YouTube keeps you watching. The AI analyzes your watch history and runs it through a formula to predict your next click. Delivery apps use a similar engine, calculating traffic, kitchen speed, and distance simultaneously to generate a 30-minute estimate. This invisible, organizing force optimizes your daily life dozens of times every single day. Right now, you carry 100,000 times the computing power of the Apollo moon landing computer in your pocket. The miracle of your phone is found in the mathematics and logic that allow the software to learn rather than just calculate. But if AI is entirely based on a system learning from data, how exactly does it process that information to teach itself? Tomorrow, we will learn about machine learning, the engine that powers all of this AI. Once you understand the mechanics of this engine, the software in your pocket will finally make sense. See you in episode 2.